Let's start our LeetCode journey with one easy task. Number 2469. Convert the temperature. We are given the Celsius number, temperature in Celsius, and we need to find and return Kelvin and Fahrenheit values by using the following formulas. First, let's start from pseudocode for this task. So we have the Celsius number as input, and we need first to calculate Kelvin and Fahrenheit values by using the formula, and then we need to return calculated values. Kelvin and Fahrenheit pair. Now, let's transform this pseudocode into C#. Since C# is strongly typed language, we need to specify the type for each variable. The given parameter Celsius is double, so Kelvin and Fahrenheit will be double as well. Also, at the end of each expression, we need to add semicolon. For the result, we have already given type inside the method signature. So let us create an explicit variable for our result and initialize it to Kelvin and Fahrenheit pair. Then just return the result. Please note that in C#, except concrete types, we can also use a var keyword. It can replace any type, and it's good practice to use var in cases where we can easily conclude the type. For example, here, it's better to keep explicit type, double, because we have here some numbers, and it's not easy to conclude whether it's integer, float, double, and so on. But here, when we are defining our array, in the same line, we have 2 times mentioned the type, array of doubles. So, since we have mentioned it explicitly while creating the array, it's completely okay to use var instead of double array, instead of explicit type, because it can be easily concluded which type is here, and there is no need to keep the redundant code, the type twice in the same line. Now we can run our code to check the result. Okay, and we can submit it also. Okay, good. So running code is for checking 3 simple examples. On the other side, when code is being submitted, all checks are being done in detail, a lot of different test cases, including edge cases, some large numbers, and so on. So both running and submitting actions passed successfully here. Now we can do some further code analysis. First, let us discuss its time and space complexity. So for the time complexity, we have only few operations, and that gives us the constant time complexity. For the space complexity, we have these 2 primitive variables, these 2 numbers, and we have one array as well. But since it's an array of only 2 elements, constant number of elements, we have the constant space complexity as well. So we successfully solved our task and discussed the time and space complexity. But even though the logic here was pretty simple, let's discuss a few more things. First, in description, we have that the given parameter Celsius is actually floating point number. And here, the type double has been given, but floating point number could be float as well. So let's check what would happen if we are using here float instead of double. So we change the type for Kelvin and Fahrenheit. And because here we have already given double, we need to convert it explicitly to float. And we need to do the same explicit conversion for all other numbers in these two expressions. And let's now try to run our code. Okay, so here we have some wrong answer. For Celsius is 15.27. We have the first argument wrong, Kelvin. It's 288.41998 instead of just 288.42. We got the close numbers, but not equal. And that's because float has smaller precision in C# than double. It comes from the binary representation of numbers in program. We will have some zeros and ones used for binary representation of decimal part. And for double, we can use, for example, around 15 digits for decimal part, but for float, we can use only 6 or 7 digits for representing decimal part. So due to the cutting of more decimal places, we have less precision with float than with double. And for this concrete value, it's not precise enough, and we are facing the wrong answer. Further, we initialized our array like this. But instead of this, we could use the following expression. First, just declare the array of doubles of 2 elements, and then add first Kelvin to result, and add second element to the result. Please notice that the first element, when we are dealing with arrays, has index 0, and second element in the array has index 1. So this approach we used initially is better in this case, when we have only 2 elements and we don't need even to specify the number of elements because they are explicitly listed here. But the second approach is good when, for example, we don't have the constant number of elements and we need to use some n number instead. And this initialization of each element could be done inside some loop, and we will initialize each element from array. With n, not constant number of elements, it's not possible to apply this initialization. Also, here we have already given the return type, array of doubles. But imagine that we can design our own function. And another type we can use for these purposes is, for example, list of doubles. But there is no need to use the list here because we know that we have only 2 elements, constant number of elements. But we can use, for example, tuple here instead of array. We need to return 2 elements. First one is Kelvin, second one is Fahrenheit, and both are double. Our result in that case will be tuple type, tuple of 2 doubles. And in that case, we will access our Kelvin and Fahrenheit values like this. Kelvin is result point item 1, and Fahrenheit is result point item 2. So notice that when we are dealing with arrays, first element has index 0 and second element has index 1. But when we are dealing with tuples, first element is actually item 1 property, and second element is item 2 property. So names of properties are starting from 1, not from 0 as indexes in the array. So we successfully solved the task and discussed some additional notes that could be useful in different cases. We covered some primitive data structures like double and float and applying some basic operations on them. Also, we saw array and tuple data structures and how to create them and initialize them, add some elements to them. Also, we discussed time and space complexity.